Since you've already figured out how your ADF works, let's talk about some of the things you'll need to know about using it. And we'll begin with this magical orb that shows navigation information. Okay, it's a dial, but it looks kind of like a cross between the VOR heads and the heading indicator. Don't leap to any conclusions though, because it doesn't quite work like either of them. In the center, you can see a plan view of an airplane. The concept is the same as the tiny airplane etched on the heading indicator. And the heart of the whole system is this long needle right here. This arrowhead points to the station. Better, it points the station out in relation to the tiny airplane at the center of the dial. If you're not sure that the needle is serious about pointing to something, or whether it just happens to be resting in that particular spot, press the ADF button. When ANT is displayed, the needle automatically parks crossways in the 3 o'clock to 9 o'clock position. Press ADF again, and if the needle returns to its original position, it wasn't kidding. If it has a good signal, it will snap over there rather briskly. Since the ADF doesn't have a visual indicator for a lost signal like the VOR does, the only way you can be sure it's staying on the job is to listen to it. This isn't as annoying as it sounds. After checking the ID, turn down the volume until you can just hear it. You'll barely be aware of the background sound, but if it stops abruptly, you'll be aware of the change. Okay, now ignore the numbers around the edge for the moment. If the needle points halfway between the nose and the right wing of the tiny airplane, then you can just bet the station is out there, halfway between the nose and the right wing of the Skyhawk you're sitting in. You could think of it as someone sitting in the passenger seat telling you where things are by extending an arm and pointing to them. And isn't that what we promised you in the beginning? Well, if you're still with us at this point, you've mastered the basic principles of ADF. First, though, we'll give you a no-brainer. If you turned your Skyhawk until the nose was pointed the same way the helpful passenger is pointing, you'd be heading toward the station. But if there were a crosswind, and when isn't there, it would blow you away from the direct path to the station. If, however, the helpful passenger kept pointing to the station and you kept turning just a little bit so that the station stayed straight ahead, eventually you'd get there. Well, if you substituted your ADF needle for the helpful passenger, you'd call the process homing to a station. It lacks elegance and adds time to your trip, but it gets the job done. That's the no-brainer solution. If you want to be more precise, then you'll have to give our pointer, whether it's the passenger or the ADF, a more precise way of describing direction than head over there. With that in mind, the solution is obvious. Let's borrow the dial we've been using for navigation and anchor 0 degrees or 360 degrees on the nose of the airplane. Doesn't really matter which direction your airplane is flying. You still anchor 0 or 360 on the nose. Now the right wing is 090, the tail is 180, and the left wing is 270, and you're in business. We call that a relative bearing system. Relative to what? Well, relative to the nose of the airplane, of course, no matter which direction you're flying. And here's an alternate and valuable definition for relative bearing. It's the number of degrees you'd have to turn to the right in order to point the nose of the airplane at the station. Of course, that's awkward for things on the left side of the airplane, and in practice, you really wouldn't want to do it that way. So trust me, always remember that the relative bearing is the number of degrees you have to turn to the right in order to point the nose of the airplane at the station. If you think of it that way, you'll thank me for all the messy negative numbers you'll avoid when you're working out the mathematical solutions. But before we do some of those, 2 more definitions, and then we promise to let it rest for a while. Directions to and from the NDBs are called bearings. They can be a bearing to, also called an inbound bearing, or they can be called a bearing from, also called outbound bearing, depending on whether you're going toward or away from the station. Quite simply, they're the courses you draw on your chart to or from the station. For example, this line, drawn directly eastward from the NDB, is the bearing 090 degrees from. And if you were proceeding toward the station, the same line is the bearing 270 degrees to the station. These could be expressed as either magnetic or true directions, but in practice, they're usually magnetic. We'll be using magnetic bearings. With this collection of definitions in mind, let's see how some addition and subtraction can put them to work. Suppose the ADF dial is showing a 220-degree relative bearing, like this. And you've got the heading indicator nailed on 270 degrees magnetic. You might want to know the heading to get to the station, in other words, the magnetic bearing to the station. Okay, you're headed 270, and the relative bearing is the number of degrees you'd turn to the right to point your skyhawk directly toward the station. And if you turn to the right, the numbers get bigger, don't they? That boils down to this neat little equation. Magnetic heading plus relative bearing equals magnetic bearing to the station. Fitting action to the word. 270 plus 220 equals 490. No way you can find that number on a compass, right? But don't panic. Instead, just subtract 360 from 490, and you'll find the magnetic bearing to the station is 130 degrees. But isn't that cheating, you ask? Oh no, if you made a 360-degree turn to the left, you'd end up heading exactly the same way, wouldn't you? Remember that trick though. If you end up with a heading or bearing greater than 360, just subtract 360. Now, there will be cases where you'll want to know the magnetic bearing from the station instead of to the station. All you'll have to do after you've found the magnetic bearing to is to add or subtract 180 degrees. Okay, so now you know about homing, which doesn't sound terribly efficient, and bearings to the station, which look more useful. Now, you might be thinking that all that math could be a challenge in the air. Well, stick around, gang, and we'll soon show you how a handy improvement in the new Skyhawk makes that math a whole lot easier.